Hi everyone, thanks so much for joining us today. My name is Keegan Marazi and I'm a Partner Solutions Architect here at AWS. Today we're joined here with Jeff.
Hi everybody, my name is Jeff Bloom. I'm the founding Principal Solutions Architect at Wiv.
So today we're going to look into something that a lot of teams building on Bedrock think about, and that's prompt caching. Can you start by explaining the difference between static and dynamic prompts?
Absolutely. Let's start with static. That means it does not change from one call to the next. It's processed once. Dynamic means that it is re-tokenized for each call. So for us, each call to Claude Sonnet on Bedrock starts with a system prompt. And ours is about 15,000 tokens because the agent needs enough context to handle a wide range of cost questions. The key insight is that most of this system prompt is static, so it stays the same. On the left, you'll see our static portion of the system prompt. Things like step templates. We have over 40 step templates, tool definitions, routing rules, and FinOps best practices that stay consistent across user and sessions. And on the right, there's the dynamic portion. Things like conversation history, tenant-specific integrations, the current timestamp, and the session context.
You know, that's a great explanation of static versus dynamic prompt caching. By adding portions of your context to a cache, the model can leverage that cache to skip recomputation of inputs, allowing Bedrock to share the compute savings and lower your response latency.
That's right. But let's look at a visual of how this works specifically to Wiv.ai. Here's a typical call. 15,000 tokens total in the system prompt. So we split it up. About 10,000 tokens are static and 5,000 tokens are dynamic. Those 10,000 static tokens hit the Bedrock cache and are processed once and reused on every subsequent call. Only the 5,000 dynamic tokens get re-tokenized fresh. That's roughly a 67% reduction in token processing per call.
You know, that's a great data point. When using Bedrock prompt caching, you're charged at a reduced rate for tokens read from cache. Cached input tokens are priced at a fraction of regular input tokens on Bedrock, so you really get double the benefit. Fewer tokens processed, and the ones that are cached cost less per token.
That does translate directly to cost savings, and you would also think it would translate to lower latency, but that's where it gets interesting.
What do you mean by this? I'd expect caching to always be faster, right?
Well, that's what we thought would happen at first. You cache everything, and then everything gets faster. But once we measured it in production, we found the opposite was true for some parts of our system. For the router LLM, which uses a much smaller prompt, caching actually made performance worse. The time to first token went from about 120 milliseconds to 280 milliseconds with the cache. So the cache lookup overhead was actually outweighing the benefit. The full agent was the opposite. With a 15,000 token system prompt, latency dropped from about 850 milliseconds without the cache to 240 milliseconds with the cache. So a dramatic difference between caching between the two LLMs.
Wow, yeah, I wouldn't have expected that, and it's a really interesting finding to come to. How long did it take for this exactly to happen? I know you mentioned that this was in production.
We noticed that after about 2 weeks in production, router LLM P50 latency went up instead of down. At first, we thought it was a bug, but after another week of instrumentation and A/B testing, we confirmed that cache overhead was the real cause.
So what did you really do with that finding? I understand that it's a small difference from prompt to prompt, but over time at scale, it could really cause an impact. So how did that finding actually impact and change the product?
We ended up going with a hybrid caching model, where each part of the pipeline gets its own caching decision based on what we measured in production. So for the router LLM, the cache is off because the prompt is much smaller and the overhead just didn't make it worth it. But for the full agent LLM, cache is on because the prompt is much larger and the token savings are substantial. And then we also keep the cache on for the RAG retrieval and the summarization because the context is heavy enough and consistent enough to make the caching worthwhile.
So that's actually sparking my curiosity here. It seems that at some point or at some threshold, it becomes worth it to cache versus it not being worth to cache. In all of the investigation and experimentation that happened, was there a specific threshold that was identified as worth caching versus not?
Well, based on what we measured, the crossover point is around 2,000 to 3,000 tokens. Below that, the cache lookup overhead costs more than it saves. But above that, caching starts to pay off. So for our router prompt at 800 tokens or so, cache is not worth it. But for the full agent at the 15,000 tokens, it clearly is.
let's shift to another part of this topic, which is knowledge bases. On one side of the coin, we have the direct context that's fit into the LLM. What the user is asking, what is the return response from the APIs. But another side of the question is what to really do with that knowledge. If we understand Bedrock, you're able to access foundation models with a unified API, but most natural language models and most foundation models are trained over a generalized set of data. So they're not going to know specifics about a specific enterprise, specific practices, or specific context regarding a user's question. This is where knowledge bases come in. A part of Amazon Bedrock are Amazon knowledge bases, which can be used to store specific user or scenario data that you want an LLM to be able to understand and retrieve given a certain question. Now, my understanding is that FinOps is pretty straightforward. How do we save the most amount of money? But Jeff, I think my question comes to the point where, why do we need knowledge bases for a FinOps solution?
Well, let's walk through it. We start with source documents, like our step documentation, help content, FinOps guides, AWS references, and customer-specific policies around tagging and cost allocation. Those are then embedded in Amazon Titan on Bedrock and stored in a vector index for semantic retrieval. Then, at query time, Claude pulls back the most relevant documents and grounds its answer in real source material, rather than relying only on model training. The result is answers that stay current and they're grounded in real documentation and can be tied back to verifiable source references, and it reduces the chance of a hallucination.
Got it. And that makes a lot more sense now. Wrapping up to see the big picture, I see how caching and knowledge bases impact common business questions, especially when trying to optimize costs in your cloud environment. Now, I guess that leads to my mind to how does that actually impact an organization over the span of days, weeks, and months?
Well, this is my favorite part because both improve over time and they compound each other. So prompt caching gets better over time, starting on day one. Cache hit rates may be about 20%. By week one, they can get to 50%. By month one, they can be up to 75%. And then consistently about 80% or above beyond that, which means the same query literally costs less each time it runs. At the same time, answer quality is improving because your knowledge base is growing. And we're adding more documentation. We're updating existing content. We're refining our FinOps guidance. RAG responses become more accurate over time with that. As a result, the system is getting cheaper and smarter simultaneously. So the agent optimizing your cloud costs is also optimizing its own.
That's a great observation, and I'd like to tie it back again to the AWS well-architected framework where we're looking at cost optimization not only on a day one impact, but on weeks and months. And given that we're talking about FinOps tools, it's important to make sure that the tool itself is not increasing our costs and causing unnecessary spend. So can we tie this back a little bit into the orchestrator and how the LLM is actually making these calls from a natural language prompt and how it kind of connects to the ultimate question that we proposed at the beginning?
The orchestrator benefits from both of these capabilities. Prompt caching makes each orchestration round faster and more cost efficient, which matters because a single investigation can run through multiple iterations, each with its own API calls. And the knowledge base is adding grounded context into every step of the orchestrator. So it's not just moving faster, it's making decisions based on real documentation. And that really is what brings together all three videos and topics. In the first video, we talked about the multi-integration engine as the hands, the part of the system that's going to reach into AWS and execute the right calls. In the second, we described the orchestrator as the brain, the part that decides what to investigate next and how to reason through the results. In this video, the caching and the knowledge bases are really the memory, the part of the system that makes it more efficient, more informed, and more reliable over time. So putting this all together, integration handles the API calls, orchestration handles the reasoning, and caching plus those knowledge bases provides the memory, efficiency, and grounding that make the whole system practical at enterprise scale.
Great way to close. Thanks again for sharing these insights and showing how a FinOps tool can really impact the ROI at a day one basis all the way up to many months and years ahead.
Well, thank you for having me. If you'd like to explore Wiv further, take a look at the links in the video description, and you can find us on the AWS Marketplace as well.